Correct answer. What is wrong with A? It looks very close, but it's not quite. Sizer.
Well, it says angle FCB, but there's no line between C and B.
There's not even FCB, right? So what you would actually have to do, if I said FCB, you would have to draw an angle in. You'd have to do this. And that looks pretty useless on there. So it is going to be B. I'm going to put it in a different order. The only time you can reorganize it is you still have to keep your vertex in that middle slot. So I could change this to C, F, B, and angle E, F, D. Do we all agree that's the same answer? Yeah. As long as my vertex is in the middle. As long as my vertex is in the middle. Can someone name an angle that is a complement of AFI? That's how you pronounce it. AFI. AFI. Davian. EFD. Yep. Angle EFD. Name two congruent supplementary angles. What you should think in your head, before you even answer this, I see a lot of people have the answer, but what I'm thinking in my head is congruent supplementary. Same size as to 180. It has to be what does the measure have to be? What was that talking about? Has to be 90. Each one has to be 90. No, you had 180. Like the total is 180, right? But each one has to be 90. Can someone name those two angles that are congruent and supplementary? Congruent and supplementary. Libby?
BFC and EFD.
Did I get those right?
No.
Did I write down what you said?
Yeah.
BFD and EFD. I'm going to say those aren't congruent or supplementary. Congruent, they have to be the same measure, right?
Oh, yeah.
BFC. Oh, you know what you named? Vertical angles.
Oh.
Those are both vertical angles. So they are congruent. I'm sorry, they are congruent.
Yeah.
But do they add up to 180 degrees?
No.
No. Can someone tell me what the two angles that are... Let's get rid of those. Yeah, go ahead, EJ.
AFB and AFD.
AFB. And what did you say for the second one?
AFD.
AFD. Do you see how when you put those two together, they'd equal that 180 degrees? Mm-hmm. Yours were just vertical angles. Don't get those confused with them.
Okay.
I think last time we had this exact same picture, I did ask for vertical angles, if I remember correctly. Is everyone okay with all those answers? Okay. What I'm going to do today is, well, quit getting ahead of myself. Questions from the homework. Let's handle that first, because those proofs are important, because you're going to be almost repeating those proofs again today. And if you don't know what happened in those proofs, then today is going to be even harder. Who has questions from the proofs? And I don't mind walking through an entire proof if you're just like, I'm not quite sure where you got that from. Yeah, Libby. 5. Do you want me to go through the whole thing, or do you have a specific question?
The whole thing.
The whole thing, okay. I'm going to take a picture of 5, and we'll just go through the whole thing together. Did you guys kind of notice they're all kind of the same proof?
Yeah.
They're all kind of like set something equal to 180, set those equal to each other, and somehow subtract something out. Do you think that's important to know how to do these proofs? This one kind of style thing? Guess what the proofs look like today?
The same thing.
Pretty much the same thing. So that's why I was like, I'd much rather just go through one of these than to not. All right. Let's use that photo. Let's make stuff disappear. Oh no. Where are you going? There we go. Now we have a fresh slate. We have a fresh slate where I can make a T-chart, where I can have my statements, and I have my reasons. Generally speaking, these kind of follow a pattern where I want to link a bunch of stuff together, where at the end of the day I can get to 1 to 4. So what I'm looking at is I look at the picture and I look what's given and I kind of think through it. I want all these stuff to be linked together. Well, they linked 2 and 3. I somehow want to get from 1 to 4. What property would help me get in that direction? I think that's a terrible way to phrase that question. Let's see if you got it. Second. Well, we are going to use the transitive. Yeah, that's why I said it was just a horrible way to set that question up. I want a link that goes from 1 to 2, 2 to 3, 3 to 4. We already have the 2 to 3. How do I get from like 1 to 2 and the other ones? Yeah. How do I get from like 1 to 2? Vertical angles. And we have a theorem 4, vertical angle theorem. So can you see, I'm not going to write anything down. This is what you should be thinking about in your head without writing anything down. Because at the end of the day, if you have no idea how to write the proof, just write what information I'm kind of giving you right now. Like I would go, okay, Mr. Bateman, I don't know how to do this proof, but I can create a chain. I can say 1 and 2 because of vertical angles. I can say 3 and 4 because of vertical angles, and 2 to 3 because it's given. I don't know what else to do, but I know that's a strong link. That's enough to give you a lot of points on this proof. If you just write that stuff down and give me vertical angle theorem, that's why I said that stuff. But that's the general idea of this proof. So let's go ahead and start with our statement. The first thing I'm going to do is my given. So that is angle 2 is congruent to angle 3. And that's my given. And honestly, if you have no idea what to do, look at the picture, look at your given, and see what you can interpret. So without knowing anything, I'm going to go, well, Mr. Pavian probably didn't set up these vertical angles for me not to use them. So even if I had no idea where to go, I'd go, okay, the vertical angles, let's list that information because that's, even if I don't use it, I can still list it and not use it. So I would automatically, just in the back of my mind, I'm like, okay, we already have vertical angles, let's use those. So I'll say angle 1 is congruent to angle 2. I would go with angle 3 is congruent to angle 4. And that is our vertical angle theorem, or theorem 4, right? I forget the numbers.
4.
Yeah. I forget the numbers because that's not a huge thing. We were taking pictures.
Yes. Yeah. If you have a problem, you have to check it out. Excuse us. Yeah.
I took pictures and I got done fast.
Because you can use it.
Oh, that's what it was. I skipped the whole line. Why do you guys just do that?
All the teachers skipped in front of us.
Oh, jerks. I would not have done that unless you were in the room when I did it and saw me do it. Otherwise, I didn't do it. Hey, guys, I need a link that gets me from 1 to 4. I have 1 to 2, 2 to 3, 3 to 4. Do we have that link?
Yeah.
Are we done? Yeah, what's my last step?
Angle 1 is congruent to angle 4 because of the transitive postulate.
Because of the transitive postulate. Would substitution work there?
Yes.
Probably.
Probably. Would it be your best answer? No. Transitive is always best if you create the links. Technically, it's kind of substitution because you can keep substituting stuff in. Like we know 2 is congruent to 3. 3 is congruent to 4. So I could replace that 4 there. And because so you're actually using substitution a couple times. Would I accept it on a test? Yeah. I'm more concerned about this. I'm more concerned about your logic than getting these 100%, as long as you get one close. If you say something like angle addition postulate, then we have a problem because we didn't use the angle addition postulate at all. All right? Just get these logics down. Did that help out in that one? Other questions from the homework? Like a second talking about today. I'm not even going to go through all of these proofs. In fact, we're going to start here. And the only thing I'm going to give you is, do you see how it doesn't say prove or show or anything up here or what's given? In that case, we don't know what happened in this first step, so it's always assumed if they didn't give me any information, That has to be what was given to me, because I had nothing else to base it on. So if you have nothing else to base it on, your first step is given. You do the rest of that one. All right, we're going to start this one together, and once again, I'm going to get to a stopping point. I'm going to make you finish it. All right, first step, let's write our given. Hey, that's points. Mr. Pabian, I can always get 1 point on these proofs. And that is your given. I'll be honest with you, there's no reason any of you shouldn't get half points on these proofs, because it really is write your given and then give me some kind of steps that show you're following something. Labib.
Is the next one division property equality?
On this one?
Oh, on that one.
Yeah. In fact, I think it'd be multiplication, because you're multiplying by 2 on both sides.
Oh, right.
So like you're almost there. But we're on this one. Anyone want to just guess at what the next step is? And here's my hint. RP is that long. I want to eventually get to this total length. How do I go from segments to a bigger length? Yeah. Segment addition postulate. So without me even knowing anything, I can go, well, I need to get from these small segments to the big one. So why not do that right off the bat? Why not go, well, I know that RP plus PS, that's an R, equals the total distance R to S. I also know that TQ plus that QS equals that TS. My second step is that segment addition postulate. I need to somehow get RS equal to TS. This is kind of where you need to... All right, we just went off of the proof. We went off of, this was given to me. I know I need longer lengths, so I didn't even follow any kind of structure. I just did something. Here's where we have to look back at the given, because there's nothing else I can do with this. I can't substitute this in for that right now, because they don't both equal 180. If they both equaled 180, then we could substitute it in, so I can't do that. So I'm going to look at my given. I'm going to look at my given and say, well, if RP equals TQ, wherever I see RP, I can replace that with TQ. Wherever I have PS, I can rewrite that as QS. Substitution lets me do that. As soon as something's equal to it, I can write either or wherever I want to. So see if this is going to make sense to you. I am going to square off some things that I'm going to substitute in the next step. So RP equals TQ. So my third step, I'm going to replace RP with TQ. I'm going to replace that PS with QS, but I'm going to leave the RS there. And that is substitution. I'm going to stop right there and let you finish it. It's just one more step. It is just one more step, and I'm going to let you think about. Ask yourself, why did Mr. Pabian do that? How does that help me? And that can help lead you to the next step. All right, so you need to finish that one for homework. What was that? Kind of. Well, no. All right, theorem. If two angles are supplementary to congruent angles or the same angle. But then look at our given. It talks about complementary. If you're confused, you should be. Because what we're going to do is go back to our theorem sheet. We're going to go back to our theorem sheet where it says if two angles are each supplementary. I'm going to add a little bit to that. I'm going to say if two angles are each supplementary or complementary, so that theorem will suffice for if it's complementary or supplementary. So supplementary or complementary, theorem 5 will work for either one of those. So if we go back to the actual problem, what it should actually say, instead of supplementary, we are going to prove that the complementary version is also true. So we're basically going to prove the complementary portion of what we just added. That's what we're going to prove here. Do you think this proof is that much different than proving the supplementary one we just did yesterday? Nope. Do I want you just copying word for word what you did yesterday? Nope. I want you to try it without even looking at it. I want you to try this one without even looking at the one you did yesterday. That's all I'm going to say on this one. This guy right here, I have to write some letters in. I realized I didn't write it. See how it says AC is perpendicular to BC? I need an A, I need a C, and I need a B for that to make sense. So make sure you write those in. We're going to start this one, yeah.
If the given is long, can you just put like SC above?
Like I did?
Yeah.
Yes.
So we can do that on the test?
Yes.
Okay.
But don't abuse it.
Yeah.
I don't want to see as seen above every single time. Like this one isn't that hard to write, so
Yeah.
I might write this one. But yes, if I give you, especially on a test, because tests are timed last time I checked, and I don't want you writing down a whole bunch of givens that you could just write as seen above. Let's start this one together. So step one, I'm always good at it because it's just the given. AC is perpendicular to BC. Angle 3 is complementary to angle 1. That's actually a lot of information. So one tip on some proofs, more complicated proofs, is your first step is actually to unpack what the given means. Unpack what it means mathematically. Can someone tell me what it means to be perpendicular? And don't just tell me they intersect. They intersect at a very specific way. 90-degree angle. So if AC is perpendicular to BC, this angle is 90 degrees. So by unpacking that, I'm allowed to say that angle 1 plus angle 2 is equal to 100, I mean not 100, just 90 degrees. Yeah, thank you. And that is just definition of perpendicular lines. Do you see how I just unpacked it? I took what they gave me and I said, why is that important? What does that mean? Kind of like the second one. The second one says angle 3 is complementary to angle 1. How do I unpack that? How can I unpack that? Yeah.
Angle 3 plus angle 1 equals 90 degrees?
Yeah, angle 3 plus angle 1 equals 90 degrees. The reason this is a little it's not actually tricky, it's just not something that's on our sheet. It is not something on our sheet. Does anyone venture a guess at the reason for that? Don't overthink it. Don't overthink it. Isn't actually on your sheet. My hint is that's what it means to be complementary. Sangha? Given? It's not given. There's a reason I could say if, yeah.
What's the definition?
It's the definition. And if you look at your sheet, you don't have a definition of complementary, but I didn't write every single possible definition you'd use. In short, if you're just unpacking what it means, it's a definition. I'm unpacking what it means to be perpendicular by saying it's 90, definition. I'm unpacking what it means to be complementary, it's definition. if it's something simple, if it's something that you just know, like complementary 9 degrees, you're better off erring to saying it's the definition than making up a postulate for it. Or if it's something simple that you just kind of know, I know that a complementary, I know that a supplementary equals 180 or something like that. Lean towards definition if it's at the end of the, you're in the 11th hour, you got 2 seconds left to answer it. Yeah.
I was going to do the next step.
Don't do the next step. I'm done. You have to finish the rest of this as well.
All right.
All right? And that's all I'm doing with you, because if you look at the last two, do those look familiar? Like you literally just did them for homework, and we actually just went over one. All I want you to do, fresh sheet, do it on your own. All right? Don't look at your notes. All you can use your postulate and theorem pack and see if you can do this all by yourself. If you can't, and you have to go back to your other notes, that tells you need to practice even harder on these, okay? Does that make sense? So I want these last two, you're pretending like they're fresh new problems. You're not going to use your notes at all. You're just going to use your postulate and your theorem sheet. Pretend like it's a test. It's a test, you know those last two. Because we just did them yesterday. We went over one of them. All you can use your postulate and your theorem sheets to finish those. Any questions for me? All right, the rest of the time is yours to work. I am going to walk around and I'm going to check your homeworks with an S. I didn't check your homework yesterday, I don't think. So I'm going to check yesterday's, the stuff that was due yesterday and the one that was due today.